Welcome back, dear students. Today in this video I am going to discuss about the determination of point group in some simple molecules. What are the steps and procedure to determine the point group if you are given a specific molecule? Okay, welcome once again. Actually, there are two types of naming system to determine the specify the point group of a molecule. That is Schoenfly symbol and Hermann-Morgen symbol. And in molecules, we are mainly using Schoenfly symbol. Hermann-Morgen symbol is mainly used for crystal system. Okay, today in this lecture, I will use this symbol, that is Schoenfly symbol. In Schoenfly symbol, we are using point group denoted like C2V, C3V, D4H, like that. There is a alphabet in Schoenfly symbol, and that alphabet denotes, for example, the C is the alphabet that denotes the proper rotation axis. C denote the proper rotation axis. If there is an S in the point group, that denote the highest order improper rotation axis. Okay, and if there is a D, symbol D in the point group, that denote the in this symbol is used in the case of the highest order rotation axis Cn plus a perpendicular NC2 axis. That is, if D, the symbol D is used only when there is a Cn axis in the molecule, and in addition to the Cn, there are NC2 axis perpendicular to Cn. Then we are using the symbol D. Okay, then the symbols like T, O, I, etc. used in the case of T is used in the case of tetrahedral molecules or tetrahedral point group. O is used in the case of octahedral molecules. I is used in the case of icosahedral molecules. Okay, and the number in the point group, that is, you may see that symbols like C2V, and that 2 indicate the highest order rotation axis. In this case, C2V means 2 means second order rotation axis is the principal axis, or we can say it is D4H. And this 4 indicates there is a C4 axis. That is, the highest order rotation axis is C4, or we can say there is a point group like C6H. Then that indicates there is a C6 axis, or we can say there is a point group like D3H. Then that this 3 indicates there is a third order rotation axis, that is C3 axis will be there. Okay, and the subscript letters like V, for example C2V, this V indicate there is a sigma V plane, or for example there is a point group like C3H, and this H indicate there is a sigma H plane, or we can say there is a D2D point group. The point group D2D means there is a sigma D plane is there. Okay, so that subscript letter indicate the different types of planes. V indicate vertical planes, H indicate the horizontal plane, the D indicate dihedral plane. Okay, let's move to the more details of this classification. Okay, first we are discussing about the molecules of low symmetry. Okay, there are some molecules having very low symmetry, and main category of this type is group C1. C1 means it has only E, no other symmetry axis will be present. In the point group, if the point group C1 means molecules has no other symmetry element except E. We know that E is a symmetry element, that is identity element, is present in all molecules. Okay, that is a trivial symmetry element. So in that point group, there is actually E is equal to C1. So this type of molecule is called C1. It is a highly unsymmetrical molecule. The examples are very rare. One of example is CFClBri. This one example belongs to C1 point group. This molecule CHClBri. It's a tetrahedral molecule. This molecule has no symmetry element except E. So this molecule belongs to C1 point group. Another type of point group belongs to low symmetry is group CS. CS means in addition to E, it contains a sigma plane. Okay, that is only two symmetry element. E is already a trivial symmetry element. In addition to E, only one symmetry element, that is sigma plane, and that is called CS. For example, a molecule like HOD. This molecule has a planar symmetry, sigma H plane, sigma plane. Then the molecular plane is a symmetry plane. No other symmetry element is present. No rotation axis, no improper rotation axis, no other symmetry plane. Only one plane. This plane is present. So this molecule belongs to CS point group. CS point group means it has only a plane of symmetry in addition to the identity element E. Okay, so this also examples are very rare. Some unsymmetrical planar molecule belongs to this category. Very unsymmetrical planar molecule belongs to this category, that is CS category. Another type of low symmetry is group CI. CI contains, in addition to E, it contains inversion center. Okay, a center of inversion is present. This is also very rare case because only I means very complicated or very rare type of molecule. And one example is all trans CFHCl. This type of molecule belongs to group CI. I'm not going to draw the structure of this molecule. If you draw the structure, you can see that it has only an inversion center. No other symmetry elements will be present. Okay. Okay, I will draw the structure. The Newman structure of this molecule, all trans CHClBr is all trans. That is one H is here, this H is here, Cl is here, Cl is here, and F. This is all trans CFHCl. Okay, this molecule you can see that there is a center here. If you draw a line towards this and externalize this line, we can meet fluorine. Okay, like that, this hydrogen, this Cl, this Cl. Okay, no other symmetry element is present. It has only the inversion center. So this molecule belongs to CI. These are the three type of molecules having low symmetry. That is C1 contains only identity element. The other is CS. It contains a symmetry plane in addition to E. And other is CI. It contains inversion center in addition to the identity element. Okay. Next, moving to the molecules of high symmetry. In this category, the first category is group CN. CN means it contains only the CN rotation axis. Okay, so we know that in CN axis there are n other or n symmetry elements along with the CN. For example, if there is a C3 axis, we know that there is C3 means C31, C32 and C33. So no other symmetry plane or no other inversion center like that is present in the case of CN, only a CN axis. Okay, so the order of this type of point group is equal to n, because if CN is present, along with the CN there will be n other rotation axes. For example, if C3 is present, C3 contains inherent symmetry operations like C31, C32, C33 like that. For example, if C4 is present, C4, if a molecule contains C4, it must always contain C41, C42, that is C2, and C43 and C44. C44 is actually E. So there are 4 symmetry operations. Therefore, order of this type of point group is n. Okay, I think you are clear. The examples of this type of molecules are very rare. Some example is for example C3 point group, molecules having a C3 point group is known. The example of a molecule having C3 point group is triphenyl phosphine, PPS3. Triphenyl phosphine molecule has only a C3 axis, no other symmetry operation. Only inherent symmetry operation of C3 is present. No other symmetry elements are present in the case of triphenyl phosphine. So this molecule belongs to C3 point group. Other examples are very rare, so I am not going to discuss about that. We are moving to the next type, that is CNV. CNV point group means it contains a CN axis, and in addition to Cn there will be n sigma v planes present. Okay, so CNV point group means it contains Cn axis and n sigma v. These are very common type of point group. For example, C2V. C2V means it contains C2 and 2 sigma V's are present. Example for this molecule is water molecule, H2O. H2O molecule has a C2 axis and it contains 2 sigma V planes. One sigma V plane is this, another sigma V plane is this. Okay, so this molecule belongs to C2V. Okay, generally all pyramidal molecules, pyramidal type of molecules belongs to CNV category. For example, NH3, that is trigonal pyramidal. Okay, this molecule belongs to C3V point group. And square pyramidal molecules, molecules having square pyramidal, for example, XeOF4. XeOF4, it's a square pyramidal molecule. Square pyramidal molecule belongs to C4V because it has a C4 axis and 4 sigma V planes. Okay, so C4V. And the order of this type of point group is, and there are n symmetry elements in Cn and addition n sigma V planes. Therefore, the order of this type of point group is 2n. Okay, the order of CNV type of point group is 2n. Okay, this is a very common type of point group, CNV, that is it contains Cn axis and n sigma V planes. Okay. Okay, next category of molecules of high symmetry is CNH. CNH means it contains a Cn axis plus a sigma h, a horizontal plane. Okay, so this molecule contains a Cn rotation axis and a perpendicular plane. Okay, for example, molecule like C2H. C2H means it contains a C2 axis and a sigma h. Okay, molecule belongs to C2H point group is hydrogen peroxide. Hydrogen peroxide shape is an open book like structure, we know. Okay, there's a C2 axis here and a sigma h plane, perpendicular sigma h plane. Okay, this is the C2 axis passing through this perpendicular to this board or this plane, and sigma h is this molecular plane. So this is a horizontal plane, sigma h. Okay, so this molecule belongs to C2H. Another example is C3H. Molecule is H3, planar H3BO3 molecule. Planar H3BO3. H3BO3 structure is like this. Okay, and this planar sector, it has another sector, a non-planar sector that belongs to C3 point group. But planar H3BO3 belongs to C3H point group. There is a C3 axis passing through this center of this boron and perpendicular to this plane, and there is a sigma h plane. Okay, order of this point group is also 2n because Cn contains n symmetry operation and Cn plus sigma h generate other symmetry operations like I and Sn, etc. So the total number of symmetry elements will be 2n in this case also. Okay, and that is CNH. These three are the C category. That is C, CNV and CNH. C means it contains, sorry, C, it's not C, it's CN. CN means contains only rotation axis, no other plane of symmetry and inverse center like that. CNV means Cn plus n sigma v. CNH means Cn plus a horizontal plane of symmetry. And that is the three types of C category point group. The next category is DN, D category. Okay, a molecule has a Cn axis. Dn means it has a Cn axis and NC2 axis is perpendicular to Cn. Okay, actually D category is this. D category means Cn plus NC2 perpendicular. Okay, there is a Cn axis, proper rotation axis, and there are NC2 axis perpendicular to the Cn, and that belongs to D category. And Dn means it contains only Cn and NC2 perpendicular Cn, no other plane of symmetry and inverse center like that, and that belongs to Dn category. This is a rare type of category. Actually this Q type molecules belongs to this category. Skew type, skew conformation. For example, skew conformation of ethane, C2H6, it belongs to D3. Okay, and skew conformation of some other molecule also belongs to Dn category, and it's also a rare type of category, Dn. And next is DNH. DNH means Cn plus NC2 perpendicular to Cn, that belongs to D category, and plus there is a sigma H plane. Okay, that is in addition to D, Cn plus NC2, that is a D category. So in Dn, this is Dn. In addition to Dn, if there is a sigma H plane, that belongs to DNH point group. Okay, it's a very common type of category. All planar molecule belongs to this category, planar molecule. For example, BF3. BF3 is a trigonal planar molecule. This molecule belongs to D3H because there is a C3 axis here, and NC2. This is one C2, another C2, and another C2. 3 C2 axis. So there is a C3 plus 3 C2. And a sigma H. This is a planar molecule, therefore this is sigma H. Okay, some other examples of, for example, PTCl4, square planar molecule, PTCl4. Okay, there is a C4 axis passing through this platinum and perpendicular to this board or this surface, and there are 4 C2 axes. This one C2, another C2 here, another C2 passing through this 2 chlorine, another C2 passing through this 2 chlorine, and there are 4. There is a sigma H plane here. This is a sigma H plane. So here there is a C4 and 4 C2 plus sigma H. So this molecule belongs to D4H point group. And that is DNH category. But DNH means Cn plus NC2 perpendicular to Cn, that is Dn, plus an additional sigma H plane. And order of this point group is equal to 4n. Because n from this Cn and NC2 from this here also present. So this is 2n plus sigma H and C is Cn and sigma H belongs to another 2n type, 2n point groups like say Sn axis and I, etc. Okay, so the order of this point group will be 4n. The other categories, next category is DND. DND means it contains Cn axis plus NC2 perpendicular to Cn. Okay, that is a must for a D category point group. Plus, in addition to that, there are n sigma D planes. Okay, so DND means there is a proper rotation axis and NC2 perpendicular to Cn, and there will be n sigma D planes. all staggered molecules belongs to D and D point group. For example, one example is allene. Allene is actually a staggered molecule. This two H are in the plane. The other two H are perpendicular to these two hydrogen. That means these two hydrogen and these two hydrogen are staggered. This molecule belongs to D2D point group. And for example, staggered ferrocene. You know ferrocene, molecule of ferrocene. Iron is center, and the other cyclopentadienyl group is staggered to this cyclopentadienyl group. This molecule belongs to D5D point group. So all staggered molecule belongs to D and D. All planar molecule belongs to D and H. I already told you. All planar molecule belongs to D and H. All staggered molecule belongs to D and D. All skew type molecule belongs to D and okay. And pyramidal molecule, I told you, pyramidal molecule belongs to C and V. Like that. So if you study this category, you can easily predict the point group of molecule in examination. Okay. So next category is Sn. N is even. No Sn point group with N is equal to odd is present. So Sn with N is even is a rare type of point group. It contains only improper rotation axis and inherent Cn axis. If there is a Sn, N even, there will be N by 2 Cn axis will be present. N by 2 C will be present in the case of Sn axis. So no other symmetry plane like that is present. It is also a rare type of point group. Sn point group is a rare type. The order of this point group will be 2n. Next is molecules of special symmetry. The first one is linear molecule. Linear molecule has two types of point group, that is C infinite V and D infinite H. Okay. D infinite V is linear non-centrosymmetric molecule belongs to C infinity V. Okay, that is C infinity molecule has no centrosymmetry. It's a linear molecule but they have no centrosymmetry. For example, HCl. Okay, HCl. It's a linear molecule which has no centrosymmetry. So here there is a Cn axis. So C infinite axis. And there are infinite sigma V planes. I am not explaining this. Already we have explained this type of symmetry elements in our earlier classes. So I am not discussing in more detail. You know that there are infinite number of sigma V planes along this axis. This is the highest rotation axis, that is C infinity, because rotation at any angle will generate same type of configuration. Therefore, this is a C infinity axis, and there are an infinite number of planes in this axis. All planes in this axis are sigma planes. So it contains C infinity and infinite number of sigma V plane. So the point group of this type of molecules are C infinity V. So all heteronuclear diatomic molecules like HCl, HCN, etc. belongs to C infinity point group. Whole heteronuclear diatomic molecule and non-centrosymmetric polynuclear linear molecule like N2O, N double bond NO, this type of molecule, or we can say NCO. Okay, NCO type molecule. This type of molecule which has no centrosymmetry but linear category belongs to C infinity V point group. And D infinite H cases, the other type is the other linear molecule point group is D infinite H. These are linear. This point group belongs to linear molecule with centrosymmetry. Okay, for example, H2. homonuclear diatomic molecules, H2. It has a C infinite axis. This is C infinite axis. And there are infinite number of C2 axes passing through this. Infinite number of C2 axes. These are all our C2 axes. C2 axis. Okay. So it contains C infinity plus infinite number of C2 and infinite number of sigma V. Infinite number of sigma V and sigma H is also present. A sigma H plane is here. Okay. So the point group of this type of molecule is D infinity H. So all linear molecule with a center of symmetry belongs to D infinite H point group. For example, carbon dioxide. Carbon dioxide is a linear molecule with a center of symmetry. So this molecule belongs to D infinite H point group. So linear molecule with no center of symmetry belongs to C infinity V. Linear molecule with center of symmetry belongs to D infinite H. That you have to remember. Okay. Okay, next category is molecules containing multiple higher order axes. Molecules containing multiple higher order axes. And this is a special category, special type of molecule. For example, first case is tetrahedral molecule. Tetrahedral molecule belongs to T category. And T category, actually it is three type, that is T and TH and TD. Actually, a regular tetrahedral molecule belongs to TD point group. In TD point group, there are total 24 symmetry elements are present. That is, it contains 8 C3 like that. Okay. And other type, next category of molecule containing multiple higher order axes is octahedral point group. This is also three type, that is O, OH, okay, O and OH, these two category, O and OH. And this OH belongs to regular octahedron. If molecule is regular octahedron, its point group will be OH. The number of symmetry elements in OH point group will be 48. Okay, next category is icosahedron. Icosahedron, that is I or IH. Okay, and these are special type of point group. For example, the point group of CH4. CH4 is a regular tetrahedron. Its point group is TD. Number of symmetry elements is 24. For example, S sub 6. S sub 6 is a regular octahedron. Therefore, its point group will be OH. Number of symmetry elements is, that is, order of the point group is 48. Okay, like that is, for example, molecules like B12, H12. This is an icosahedron molecule. Its point group will be IH. Okay. So these are the different types of point groups. Okay. Now we want to discuss about the how to determine the point group if you given an example is given in the examination. Okay. I think we can discuss in that thing in the next video. That is, in the next video we will discuss about the what are the procedure. There is a systematic procedure to determine point group of a molecule, of a given molecule. There is a systematic step and systematic procedure. I think we can discuss that in the next video. Okay. Thank you all of you. We can stop here. Thank you.